Alright, 9.1 video notes, Polygon basics, a couple learning targets up here at the top. Find the sum. Remember, sum means you're adding. So add up all the measures of the interior or the inside angles of a polygon. And then we got to do the outside as well. I'll give you two different ways to do this. And you don't have to know both ways, but some problems are easier if you know one way, some are easier or faster if you know the other. So really you could just pick one, but it's probably best to know both. Alright, so let's get after this. Some of the inside angles. So hopefully you remember from the last 8 chapters we've done. Big idea is that triangles had 180 degrees in them. And we can use that fact to kind of develop all the other polygons. Polygon, just, it's kind of a weird word, but it really just means many sides. So polygon is just anything with more than 3 sides. A diagonal, kind of another little vocab word here. A diagonal is when you connect corners, or fancy word for corners, vertices. So for instance, a diagonal would be like that. That'd be considered a diagonal. That's going to kind of help us out because 4 sides, quadrilateral has 4 sides. Basically, when you draw a diagonal, you have 2 triangles here, which is going to help us find the number of degrees in any quadrilateral. Because I can break it up that way, when I add up these 3, that's got to be 180 degrees. But then when I put these 3 with it, that's another 180 degrees. So we find out that a quadrilateral is 360 degrees. I'm going to scroll down a little bit so we can kind of fill in the chart as we go. Go to full screen. Boom. So let's go ahead and let's kind of fill out this table and these charts. So quadrilateral was 2 triangles. So 3 sides. Triangle has 3 sides, 1 triangle, which is 180 degrees. The quadrilateral we just did has 4 sides, which later on we're going to call that n. But 4 sides can be broken up into 2 triangles. So you multiply 2 by 180. So we now know, and hopefully you already did know, that all quadrilaterals, regardless if you're a square, rectangle, rhombus, trapezoid, always adds up to 360. And basically every time you add a side, you add another triangle. So if we do diagonals here, there's 1, there's 1. So I've broken this up into 3 triangles. So 3 180s, which would be 540. And the pattern goes every time you add a side, you add another 180 degrees. So this is 5 sides, 6 sides, 7 sides, 8 sides. So kind of filling in the diagonals. That would be 4. And I'm just randomly starting from a certain spot. This would be 5 triangles. And then ultimately, you would be at 6 triangles. Be quick. So 6 times 180. So I fill in the chart. 4, 5, 6. That's 720. Add another $1.80. That's 900. Add another one to be 1080. All right. Yeah. Don't be too long. So basically, if I wanted to jump to something with a lot more sides, say I wanted to do like 25 sides, I wouldn't want to have to keep drawing diagonals and drawing shapes. So there is a pattern here. If you kind of look at the chart up above, when you look at the number of sides n and you look at the number of triangles, it's always 2 less. It's always n minus 2 will give you the number of triangles. So there's a formula or a theorem that you can use called the interior, the inside angle sum. So basically it is the number of sides subtract 2 times 180 degrees. And that should give you how many degrees are in any shape. So for instance, let's say you had something with 16 sides, which we're just going to call a 16gon. If I wanted to figure out how many degrees was inside that, I would do 16 take away 2, multiply by 180. So 14 times $1.80, that's 1800 plus another 720, that'd be 2520. So I know there's 2,520 degrees in a 16gon. So that should allow us to find any number of degrees for any shape, regardless of how many sides it has. Now we're going to apply a little bit of algebra to this, some algebra. It says find the measure of each inside angle. So it looks like we have some matching ones. These bottoms are going to be the same. These tops are going to be the same. So how you do this? Step one is find out how many degrees are in the shape. Well, since this thing has 4 sides, I know it's going to equal 360 degrees. I can either use a formula or just have it memorized. So now I know that when I add up all of these angles, all these guys added together, 2x plus 2x plus 1x plus 1x, it's got to add up to be 360. So combine your like terms, add up all those x's, you have 6x is 360, divide, and you find out x is 60 degrees. So now plugging that back in, let me kind of go back and wipe these out so we can see what the original problem was. When I substitute 60 in, both of these are going to be 60 degrees. And the top angles are 2 times 60, or $1.20. And hopefully it all adds up to 360 and it checks out. That's actually an isosceles trapezoid. We're going to learn that a little bit later on. Alright, we have a little parallelogram to the right over here. Since it has 4 sides, it's also equal to 360. I usually don't write out. This first step to me is optional. I'm just going to combine like terms as I go. So I'm going to do 11x and 5x. That's 16, 27. Looks like 32 x's. And then I add my constants. I got a positive 4 and a positive 4. Nobody here. So that's a plus 8. And we can kind of streamline the process and skip that first equation if you'd like. Minus 8 from both sides. Bust this out. That's what? 352. 32 goes in 352. Divide goes in there once with another 32. So it looks like 11. But they don't want x. They want to know what are those actual degrees up here. So substituting it in, 5 times 11 tells you that these two are 55 degrees. Plugging 11 in right here, 11 times 11 is 121. Add 4, it's $1.25. And these two were matchers. It's a property you're going to find out that all parallelograms share, is they have opposite angles, are congruent to each other. All parallelograms share that fact. Alright, next side. So example 2 allows us to kind of work backwards. It says, hey, we have some sort of polygon. So we're like, we don't really know the number of sides, but the inside angle is 108 degrees. So find the number of sides of the polygon. Couple different ways we could do this, but we could just solve. We could solve the formula, and we know that the number of sides subtract 2 times by 180 equals the total. Equals the total degrees. And then if you wanted to find each inside angle separately, to find, that's the total degrees, but if we wanted each one, you would just divide it by how many sides there are. So you just divide that thing by n. So this can basically find out how many degrees each individual angle is. I'm going to do a little bit different approach. So I want to kind of walk you through this, and this is going to lead me into the bottom one here. I don't know what this polygon looks like, but I know it kind of looks, it's going to start off something like that. And I know that this angle here, it says, is 108 degrees. All right. And it's going to keep kind of going all the way around and being 108, 108, 108. And if I straighten this line out right here, I create what's called an exterior angle, or an outside angle. And the thing about the interior and the interior angle plus the outside angle should add up to 180 degrees, because you have a straight line right here. So if that inside is 108, this outside is 72. So that kind of tips us off onto what an exterior angle is. This would be called the exterior out here. And I'm going to use the theorem down below where it says the sum, when you add up all the exterior angles for any shape, it comes out to be 360 degrees. So that's a nice fact about exterior angles, is that it doesn't change. Every single shape out there, the outside angles add up to 360. So I now can kind of say, well, hey, wait a minute. How many of these 72s can go into 360? So I'll do 360 degrees divided by 72, and it looks like 5 sides. Now another way we could have did this is from the table on the front. We could have kind of went in there and tried each of those numbers and divided by the sides. And so let me kind of scroll back. If you remember these two numbers, 108 degrees, and we're trying to find the number of sides, you also could have solved this problem using this table over here. Ignore that little bell. So when we had our degrees up here, we had triangle, we had quadrilateral, pentagon, hexagon, heptagon, octagon. To find each angle, you know, and this is be if they were perfect shapes, if they, like, every angle was the same. If you divide by 3 sides, that would be 6 degrees apiece. If you divide by 4 sides, you know, a perfect quadrilateral is a square. If you divide a pentagon by 5 sides, that would be your 108. If you divide the hexagon, that would mean each one is 120. Divide this guy, I think this one comes out to be kind of weird. This is the decimal. It goes 1, 2, I think it's like 128 or something. Check this one out. This one's kind of weird. 900 divided by 7, 128.57. So I always remember that one's kind of strange. And then this one, octagon, if I divide it by 8 sides, I believe that one comes out to be 135. Yep, $1.35. So this is kind of another little handy set of numbers you might want to add on that front page of notes, just to know how many degrees each one is. But we could have kind of used that table to solve that problem as well. All right, let's wrap these up and do the outside angles. So I prefer this one. This is kind of my go-to method, so I'm going to put a star there because it's easy to remember. I don't need a formula. I just need to know that every single shape outside angles add up to 360. So let's just kind of use that fact on this one. So if I keep extending sides out, I'm going to extend you out, I'm going to extend you out, I'm going to extend you out, kind of like a pinwheel here. And if I call all of these outside angles x, there's 5 of them. So 5 of those x's, 5 times whatever x is, has to equal 360. Because every shape out there, this number will never change. That's always going to be the outside number. And now I can kind of divide these out, divide both sides by 5, and I get x is 72 degrees, which is kind of what I had on that example up above. It's kind of foreshadowing a little bit, trying to lead you in this direction. Now, once you get the outside angles, then you can jump in and subtract from 180, and you can get the inside angles, which can also give you the sum. When you do 5 times 108, you get the 540 degrees. So I kind of refer to this as the outside in method. I a lot of times start on the outside of a shape, and I work my way in, playing the 180 game, and I can still get to the sum of the interior using that method. So on this particular shape here, same thing. I'm going to do an X, an X, an X, 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 and X. So there are 6 X's, which I know for all shapes are going to be 360. So we can find out these outsides are 60. So when I work my way in, subtract from 180, I get 120 for each interior angle. And when I do 120 multiplied by 6 angles, that will give me the grand total. inside. So I'm showing you how to find the sum of the interior from actually finding exterior angles first and working your way inside. So I don't really care which method you go. It's totally up to you. And let's see if we can knock out this last one. Find the measure of each inside and outside angle for an 11-gon. Alright, so I don't even know how to draw an 11-gon. It's going to be kind of weird, but it really doesn't matter because what I know is going to happen is I'm going to extend it out and call that X, and there's going to be 11 of these X's. So 11 times X is going to be 360. We can find out what X is. 360 divided by 11 is 32.72. 32.72 degrees. And then if I want to find the inside, this is going to be 180 minus 32.72, which is 147.28. Alright, so that's each angle inside there. So regardless of what this thing is, I'm not going to keep on trying to draw an 11-gon, but I know they're all 147.28, 147.28, and the grand total in the center of this thing is going to be whatever 147.28 times 11 angles. And you get about 1620. So that would be the sum. So when you write this down over here to the side, each interior would be 147.28. Each outside or exterior, I think we came up that one was 32.72. The sum of the interior was 1620. On a test, all these would be fair game. And the sum of the exterior is super easy because for every shape, it is always 360 degrees. Now, some of you may have rather have went a different way, and you can do that too. Some of you may have wished to say, hey, I'm going to use the formula. I'm going to use the n minus 2 times 180. You know, this would be what I consider called the inside out method. So 11 sides times 180. So that's 9 times 180, which is 1620. So for this one, you start with the sum of the inside from that formula, and then you start working your way outside. So I'd say, all right, 1620 divided by 11 angles, and that's where you'll find out that each one is 147.28, and then you do 180 minus the 147.28, and that will give you the outside angle, the exterior, and then the sum of the exterior is always 360. You don't even have to calculate that. So, a couple different ways. You can work from inside, you can go from outside, but those two facts, however you do it, you either have to know the formula for the sum of the interior, or know that the sum of the exterior is always 360. I prefer this one because I don't have to calculate based on the number of sides, but I'll leave that up to you. Alright, you should have enough to be ready for the practice tomorrow. See you.